Welcome to the 2024 Live Award Show for Power the Community International College Design Competition, hosted by Energy Mentors. And founding sponsors, Chart Industries, Aspen Technology, Ernst & Young, with software sponsor, MathWorks. Featuring our judges, Jill Ivanko from Chart Industries, Vika Stoll from Aspen Technology, Moy Zuawi from We Light Mali, Juan Solana from EY, and Tony Akoya from Gensler. Hello, everyone. My name is Julia Gagare, and I'm the External Relations Manager for Energy Mentors. I am pleased to introduce to you the founder and chair of Energy Mentors, Don Victory.
Thank you, Julia, and welcome all to the 2024 Live Award Show for Power the Community, an international college design competition where we invited students to reimagine the energy infrastructure behind a new community of 2,000 homes that will be affordable on the combined salary of a nurse and a school teacher. This is the first year of our annual competition, and we're proud to be offering the largest student prize pool in the world for an energy competition, $31,000, to be split between the distinguished designs and our grand prize winner, the Energy Innovators Award, at $10,000. And today we not only announced the winners, but we're going to give you excerpts from their submissions. You know, every community in the world has its own aspiration for energy, prosperity, and sustainability. And these communities have local assets, but there's also local limitations. Is there enough solar radiation? What about the wind potential? Do they have access to capital? Fortunately, we have global supply chains and technology, and who's better to bring these type of resources together to bring local solutions than rising students from these communities who are able to access those technologies, bring their ideas to the table in order to figure out new ways to power our community. So who are these people in these student competitions? Let's go to Ian Caprono, our participant coordinator, and find out about our participants this year. Ian, over to you.
Thank you, Don. Greetings and welcome everyone to Power the Community Competition Award Show. I'm thrilled to be the one talking about the teams as we kick things off here. This competition has truly been a remarkable journey, one that was fueled by the passion and dedication of the incredible minds that had the courage to take on the challenge. From the beginning, we saw a phenomenal response in registration. Teams from across the globe registered. The US and India became hotbeds of innovation, but the spirit of powering the community transcended those borders. We also had brilliant entries from Rwanda, Nigeria, Ethiopia, Germany, Vietnam, Turkey, and many more. To foster collaboration and knowledge exchange, we also had a series of office hour sessions, which were 10 to be in particular, and these were buzzing with ideas and questions that are truly inspiring to see, and it was truly inspiring to see the level of engagement. But the communication wasn't limited to these sessions. Our Energy Mentors Engage newsletter and LinkedIn page kept everyone connected, while email exchanges ensured constant flow of support and guidance. It was through the countless emails that we built bridges, shared challenges, and celebrated ideas. It was a huge moment when 12 exceptional teams submitted their designs. This wouldn't have been possible without each one of you out there. The participants who turned in, asked questions, and poured their hearts into this competition. You've all left an indelible mark in the history of Energy Mentors, and we deeply cherish the time and effort you've invested in the journey. Today, we celebrate your brilliance. So get ready to be amazed as we unveil the incredible designs that we hope will shape the future of sustainable communities. Kudos to all teams. Back to you, Don.
Thank you, Ian. And yes, we are so proud and honored by all the students who participated this year. And we hope that they got out of this the learning experience we were hoping to catalyze. Now about our judges who will present our awards. We have great diversity of capability with our judges. An electrical engineer from We Light Mali, We Light Africa. A business transformation specialist from Mexico City. An architect with experiences ranging from Africa to the United States. a general manager of sustainability from a software data and AI company, and our lead judge from Chart Industries, Jillian Ivanko, whose career path through Chief Financial Officer and now the last 6 years as Chief Executive Officer and President of Chart Industries brings the perspective that it takes technology, business acumen, and execution to drive results for clean power, clean water, and clean food. So Jill, last year when I mentioned Power of the Community to you, your immediate reaction was, count me in. What did you and the judges find, and what impressed you about this year's results? What were you looking for?
Well, thank you, Don, and it's just an honor. It's a privilege to be here. And I think the summarization is entrepreneurialism and innovation is the key to the future, especially given that the energy transition is very complex. It's going to take a hybrid approach, a diversity of solutions, and together with the solutions that I've seen in this competition, I believe we're in a really good position to move the energy transition forward. The Energy Mentors competition did not have a set scoring methodology when we started looking at this because of the fact that we believed we needed to be extremely open-minded and look at the diversity of solutions. Innovation cannot be preset or preordained, and we need to continue to innovate and move technologies forward. The great part of the Energy Mentors competition that I found was that ultimately let students share their innovative ideas without having consultants and constraints and various different ways to bring this forward. Having fewer rules around the preset construct, we were able to encourage participants to think outside of the box, challenge the status quo and the norm, and therefore continue to push this innovation forward. We judged our top innovative ideas by also considering execution. As Don said in his intro about leading successful companies, you have to be able to not only innovate, but you have to bring those ideas forward through to execution. So our judges as a team, we worked together to look at the submissions to see if teams define the needs of their target customers and community members. Giving back to your community is as important as anything else. We identified the best available technologies, and we determined how to creatively integrate those technologies into a cohesive solution as part of our judging construct. We looked to ensure that students made a pitch that delivered their solutions that would move the dial when applied in the real world that we live in today. So what do we find? I'm really excited and very happy to reveal that for the first time, not only are we awarding the Energy Innovators Award and grand prize of $10,000, but we are also awarding 3 Distinguished Design Awards, earning a cash award of $7,000. After reviewing the designs, the judges decided that the 3 Distinguished Design Awards were earned in areas best categorized as Distinguished Design for Urban Planning, Distinguished Design for Bold Creativity, and Distinguished Design for the Next Generation. So let's see who our 4 award winners are. Back over to you, Doug.
Okay, so here we go. To make our first award presentation, we have Tony Okoyo, a principal and technical director in the Washington, D.C. office of Gensler, the world's largest architecture firm. Tony has led design teams through all phases of projects and draws upon his wide range of experience, ranging from Africa into the United States. In 2022, Tony co-authored an article, Reimagining Mass Housing Development in Sub-Saharan Africa through a Circular Cities Lens. So he's published on the topics that he was judging on. So Tony, please, your thoughts and announce our first Distinguished Design Award.
Thanks, Don, and thank you to my co-judges. Thanks, Jill, for that incredible preamble. So an award for Distinguished Design Urban Planning and a $7,000 prize goes to, wait for it, Team Jellyfish for their submission, Imagine a Seaweed City. Team Jellyfish is composed of 6 students from the Gerald Hines College of Architecture and Design at the University of Houston in the United States. The team is led by Yen Ko, with co-members Yen Tran, Lucia Pogioli, Jaylin Benavides, Leslie Almira, and Lauren Smith. In the In design and urban planning, ESG goals, decarbonization targets, and policies are increasing the demand for adaptive reuse and transformation of buildings into high-performing assets and at much lower carbon costs. Not only did Team Jellyfish lean into this concept in their competition entry, but they took on the challenge of imagining a redevelopment plan for Houston North Side. Quite an ambitious plan that strives for net zero with regards to energy, water, and waste. Let's take a look at their video.
Imagine a seaweed city. The Northside neighborhood in Houston, Texas, is a community of collective remnants. Originally, Houston's oil and petroleum industry supported the community and helped it prosper during peak years of infrastructural advancements. But now, the gravitating pull of this leftover industry hollowed out and litters the site with brownfields. These are the lasting effects of industries, not uncommon in Houston's industrial-based history. Houston may be one of the fastest-growing global metropolises, home to a talented workforce that offers tremendous opportunities for companies and individuals to thrive. Yet the demand for equity remains high, and the growth trajectories of our industrial-based economy have resulted in a downward trend of jobs in our area. Our commitment is to the future of Northside residents with Houston's economy at stake. We are looking to put the future of the community as the new frontrunners of an emerging energy biofuel industry to bring about a new wave of growth and prosperity that originally encompassed the efforts of the humble labor movement, that tackles the issues of greenhouse gases from just the energy production of emerging advanced algae bioreactor technologies. With a huge commitment to harvesting water to address the overlying issues of Houston's flooding environment, water is also considered a crucial resource in proliferating algae reproduction. We include community gardens in our proposal to encourage an urban food security, allowing citizens to grow their own food or donate what they have grown. The overall site's opportunity zones from leftover industrial unused brownfields far exceed the amount of land into making this a reality. We are pleased to present our master plan that features energy-efficient buildings with the remaining left retrofitted or adaptive reuse in a community of hardworking blue-collar families. The high-efficiency building stock is based on reducing energy overall demand by 60% versus baselines. Additionally, we aim for a healthy walk-first community. Our mobility will be switching to biofuels and to a more energy-efficient technology to facilitate a walkable and transit-friendly community by electrifying the fleet, vehicles, and based on that, reducing overall energy demand for transportation by 70%, making up the balance made up by renewables for net zero energy. Energy-efficient buildings, with roof coverage of solar panels and through the grid, excess energy can be sent to other nearby buildings. Algae production takes a commitment to harvesting water. Water including wastewater is collected, filtered, and placed in photobioreactors and raceways. Through the photobioreactors, the algae temperature is able to be regulated so they do not get overheated in the summer and die. In addition to the CO2 and sunlight, wastewater provides the nutrients for the algae to thrive at a higher concentration and grow at a faster rate. Bioreactors wrap around buildings. Photobioreactor pipes are around 1 inch in diameter and they are regulated like the panels. They wrap around the buildings but are placed over the facade, while panels are the face of the south side of the buildings. Overall, 1 kilogram of algae is able to absorb 1.8 kilograms of CO2 from the atmosphere. Imagine a seaweed city. Thank you.
Well, congratulations, Team Jellyfish, our first distinguished design for urban planning. Now to make our second award, we have Vikas Dole, the General Manager of the Sustainability Industry Business Unit at Aspen Technology. Vikas received his undergraduate degree in chemical engineering from the Indian Institute of Technology, Bombay, and did his PhD work at the University of Manchester, which launched a career in energy efficiency and deploying technology. And just in April, Vikas helped launch Aspen Tech's new Strategic Planning for Sustainability Pathways process and products. So Vikas knows a thing or two about innovation. So over to you, Vikas.
Thank you, Don, and thank you to all the co-judges in this contest. It's been a fantastic journey. So in the category of bold creativity, we selected Aerodynamos. Aerodynamos incorporated 7 different technologies into their concept, and they offered up a range of possibilities. In innovation, not all ideas survive the rigors of the marketplace. Yet without daring, divergent thinking, how can we create new technologies, new possibilities? So it's important to consider all of those. Energy Mentor's mission, as I understand, is to catalyze innovation, and Aerodynamos brought forward the ideas. At Aspen Tech, we constantly collaborate with our customers and partners to explore new possibilities, new ideas, new technologies in decarbonization and energy transition, thereby accelerate the scale and the speed of innovation through our digital solutions to help the industries we serve in terms of optimization through sustainability, performance, and resilience. These multiple dimensions need to be addressed simultaneously, and therefore we are truly excited about the entry from Aerodynamos. Bringing together 7 different technologies into one ecosystem, Aerodynamos developed a multifaceted approach to create sustainable energy ecosystem. Congratulations to the team Aerodynamos. And here's the video.
Hi, my name is Mir Uzair and I am the team leader of Team Aerodynamos coming from India and pursuing aeronautical engineering at Mangalore Institute of Technology and Engineering, which is commonly known as SMITE. I am deeply passionate about the shaping a sustainable future for our communities.
7 technologies, 1 ecosystem. Aerodynamos' multifaceted approach to create sustainable energy ecosystem endeavors to revolutionize the energy landscape of Dakshina Kannada district, India, by cutting-edge methods. Offshore high wind regions are designated for buoyant airborne power generation. Agri-solar parks offer dual benefits of electricity and agriculture. Urban zones have deployment of organic solar cell technology on buildings and wind turbines integrated into structures, alongside kinetic mechanisms in gym centers and waste-to-energy technologies. A vision of a cleaner, greener district powered predominantly by renewable sources to elevate living standards, promote sustainability, and drastically reduce carbon footprints. Agri-solar parks, a 5-megawatt solar power and agri-photovoltaic project near Mudbidri, Karnataka. The solar park is divided into 3 sections, each optimized with varying heights for the solar stands and panels. The integration of monofacial solar panels, solar tracking systems, automated panel cleaning, and IoT-based crop monitoring enhances the efficiency of the agri-photovoltaic systems. The project spans 20 acres of land and facilitates the cultivation of crops including okra with an expected yield of 8 to 10 tons per acre, potentially 160 to 200 tons annually. This translates to a revenue from 7 to 9 crores annually from okra alone. On the solar front, the total project cost stands at 26.7 crores after government subsidy, with an annual revenue of 32.6 crores. Factoring in operational costs, the project demonstrates a robust ROI of 112% and a payback period of less than 1 year. Lightweight solar sheets offer an approach to energy generation for environments with structural challenges, for example, buildings with low rooftop load-bearing capacity. The adaptability of solar sheets extends to non-straight building structures, even facades and jagged roofs. 55W sheets with a weight of less than 2 kilograms make them ideal for seamless integration onto various surfaces without compromising structural integrity. The solar film utilizes cutting-edge organic solar cell technology. Comprised of multiple layers of organic semiconductors, the solar film generates electrical energy when illuminated by sunlight. The flexible design and integrated adhesive backing of the film facilitate easy installation on various surfaces, allowing for maximum exposure to sunlight. Wind. Offshore Mangalore is designated for buoyant airborne turbine that utilizes a helium-filled airship with a turbine to harness high-altitude winds. The key components include helium-filled airships kept aloft by 1,000 cubic meters of helium, reaching altitudes from 100 to 400 meters. A turbine capable of 30 kilowatts. Stabilizing fins, UV and weather-resistant fabric, double-braided polymer tethers, one of which contains copper conductors to transmit power, a ground station which responds to sensor data from the buoyant airborne turbine to search for optimal wind conditions and adjusts altitude and orientation. Buildings integrated wind turbines can be incorporated into the structural framework of large buildings. These turbines, akin to exhaust fans in appearance, are strategically placed atop buildings, capitalizing on locations where wind speeds are optimal. Unlike their horizontal counterparts, vertical axis wind turbines efficiently capture wind energy from any direction without the need for precise alignment. This versatility makes them particularly well suited for urban environments. Their design can be topped with solar panels, harnessing electricity from both wind and sunlight. In a bustling city, gym centers are abundant. In Mangalore, an initiative is underway to harness the power of human movement by installing kinetic mechanisms in gym centers, transforming the physical activities of individuals into electricity. In Dakshina Kannada district, an initiative is underway to convert community waste into electricity, where waste becomes a valuable resource and communities thrive on clean, renewable energy. 7 technologies, 1 ecosystem, a multifaceted approach to create sustainable energy ecosystem.
At the conclusion, as our journey comes to an end, let us reflect on the transformative power of sustainable energy technology. We are shaping a future where innovation, sustainability, and prosperity go hand in hand. Join us in our quest to power tomorrow, where the sunshine is brighter, the wind is blow stronger, and our communities thrive in harmony with nature. Thank you for joining us. Have a good day.
And congratulations, Team Aerodynamos from Mangalore, India, for their Distinguished Design Award in Bold Creativity. Now for our third announcement. We have Juan Solana from Mexico City, office of Ernst & Young, where Juan is a partner as the Latin America leader for business transformation in the field of energy. Juan assists companies to define and execute strategic endeavors, including their growth strategy and innovation agendas, and to help drive clarity in business model and their digital transformation. So Juan, welcome, and tell us about the third award winner.
Thank you, Don. I'm very pleased to announce this Next Generation Award. This is a very unique award that aims at pushing young generations to think how to build a better world for them and future generations. This award wasn't considered at the beginning, yet after reviewing the different applications, we saw there was an opportunity to really push young individuals around the world to rethink and think how they may help build a better world and receive a prize of $1,000 US. And the winners are Arush Amilinelli and Patram Singarika from Belrose Energy Company. In their case, they thought about a solution to address some of the most pressing challenges that the small communities in the island of Dominica in the Caribbean are facing. This island requires proper infrastructure that can be withstand the multitude of hurricanes it receives. According to Ken Silverstein, a Forbes writer, just Hurricane Maria, with Category 5 winds, hit the island in 2017 and wiped out 226% of its GDP. In addition, this island requires proper healthcare that can help save thousands of lives dying from preventable diseases. At EY, we strive for building a better working world, and this project really addressed the ambition that we have. Arush and Patram, 2 teenagers, came up with a creative project, but that may provide 2,000 families with affordable, sustainable, and reliable housing and energy using geothermal energy, wind energy, and considering other elements such as energy storage technologies in case of hurricanes. Congratulations to the winners.
Hello, distinguished individuals. I'm Arush Amilinelli, and I just turned 14, and I'm here to represent Belrose Energy Company. So before I start on the presentation, I would like to say that I'm very grateful for this opportunity to pitch this house to you, so you can buy it. And I hope you do buy the house, so you can also join in our community and become a part of it. Our project is located in the forests of Dominica. Speaking of energy, we use geothermal energy and wind energy. So in geothermal energy, there's a system where there's a well with high temperature water. This water is pumped up and turns into steam. This steam drives a turbine, and when the turbine spins, it is hooked up to a generator, and it generates electricity. It's able to generate 25 million kilowatts of energy a year, but we're only allowing it to go at 90% efficiency, so it can only give 19 million kilowatts of energy a year. Our second source of energy is wind energy. It's a horizontal axis wind turbine. There's one large turbine and it can produce 4.3 million kilowatts of energy a year. This is a 30% efficiency. Speaking of hurricanes, Dominica is very prone to them. This may be scary for you to process, so nothing will be able to get in other than the stuff you want. Well, the stuff you want will be provided. You have clean water, energy, and amazing food. Okay? And what about your house? You're just leaving it up there to fend for the hurricane. Well, your house will be made out of ICF blocks. It's one of the most sturdy types of concrete. And it was even used in Florida. This block was able to survive against Hurricane Katrina, a Category 5 hurricane. This will be able to guarantee your safety and your house's safety, so you'll be able to live in it right after the hurricane. Well, let's say something does happen. You get sick. We have a state-of-the-art hospital clinic. This will be able to solve all your problems except the major ones such as cancer. On the topic of energy, energy is actually really cheap. It's only 5 cents per kilowatt compared to the energy you probably have, which is at 20 cents. This is almost 1/4 of the price, or 25%. So you should buy a house in our community because it's safe, cheap, big, fun, and luxurious. I really hope you move to our new community because it will be the best thing for you, your family, and you'll be able to be included in a brand new community, and it will be good for the environment and good for you. Thank you, and have a nice day.
Congratulations, Team Belrose Energy Company. You know, Jill mentioned we had no rules on the competition, and they took it upon themselves not to exclude themselves. Just because they're in high school and 14 years old, they too can move forward their skills in order to try to solve the energy transition. So now, the moment we've been waiting for, our grand prize. And here to award it, we have Moise Zawai, Operation Manager and Country Coordinator for We Light Mali, a unit of We Light Africa, which is a mini-grid developer accelerating energy inclusion in sub-Sahara rural communities. And he's coming to us today, Moise, from his home city in Bamako, Mali. Moise received his undergraduate degree at the National Institute of Applied Sciences and Technology in Tunis before participating in an international exchange program at the Norwegian University of Science and Technology. A member of IEEE's, Moise's day job is literally to power communities. So Moise, on behalf of the collective judges team, please let us know why and who is the winner of the inaugural Energy Innovators Award Grand Prize. Moise, please.
Thank you, Don. Thank you, Don. I'm really honored to have been with this competition that was put together to inspire a rising generation and to bring forth a comprehensive solution that will greatly improve a community. And I think improving community starts by providing its basic rights, right? With 600 million African fellows presently lacking access to electricity. This product in a country like Zimbabwe, it's still like the 4th most imported product in the whole country from its neighboring countries as South Africa, Namibia, with only 62% of its population being connected to the grid. So the winning design here is a holistic solution addressing 5 million people community with access to multi-sourced electricity that will enable access to education, health services, and economic development, making it a human-centered design. Therefore, we judges decided to award the Energy Innovators Award along with a cash grant prize of $10,000 to be shared by a team. The winning team is Creativity and Sustainability, which is congratulations to the 2 team members who are Rosemary Moyo, rising sophomore in biomedical engineering, and Shai Verma, rising also sophomore in computer science, both attending the University of Connecticut. So congratulations to the team, and let's see the video.
is Mary Moore, and I am the team leader of Creativity and Sustainability. Welcome to our project presentation. Take a look at our agenda. The first is background and motivations, project plan for Mbizo Kwekwe, housing design and materials, energy sources, solar energy potential, emissions, trade-offs, and risk management. Motivation when we were choosing an area to design and develop for was firstly equality, access to resources such as resources and services such as resources for building our houses, services such as schools, services such as supermarkets. We also wanted to make sure they were able to access clothing, but they were also able to access the main highway as well as plumbing and electricity. So if you look at the image that I've shown from Google Map, there's an area that is in 3D. That's our project plan. Then we have this area that looks very, very dark. That's our thermal power plant within the city, but it's also one of the places, it's the main place where we will get our resources that we'll need for making materials for the building that I will go deeper in as we look at our plan. As we zoned in within that area, we looked at the statistics from my country. We have about 5 million people that need housing and a shortage of 1.25 million housing units per family and per individual. And we also looked at the need for not only sustainable housing, but affordable housing. This takes us into our project plan. We used to delve a tool on Google Earth to design a plan for housing within the area, which would give us a 3D simulation, but also an almost real-life experience because we were making the project plan on the land, online. And the beautiful things about Delve, it also allowed us to play around with the missions that we would have within this area. It also allowed us to see the sustainability of the area. It allowed us to see our solar potential and energy potential as well as transportation, which was very pretty. If you look at the image that we have on the slide, this is our development. Within this development, we scaled each house being a house per 1,000 square feet, which is about a house per 300 and something square meters, which is ideal for houses within this area. We also left some green land, which could be used for farming or which could be used for recreational purposes. And if you look at the image, these other white spaces besides the yellow buildings that show the houses, these areas can be used by the people who will be living within this area to farm or to park their cars, which is pretty common within my area. As you can see from the design, we chose a traditional approach of 3 bedrooms, 1 bathroom, 1 toilet, 1 kitchen, 1 dining room, 1 living room. We chose to have a slightly slanted roof from east to west, slightly slanted, so we could still have maximum sunlight even within our shadow hours from 2 p.m. We also chose to use fly ash for the concrete to build the house and concrete for the roof, wood for the doors, and concrete for the veranda. We'll be getting the concrete from the nearby power station. For energy, we'll be using solar energy and electricity from the grid, and we'll also be using natural gas for cooking. Energy sources. As we took a traditional route, you might be wondering what we're gonna be doing for energy sources. We'll still have the electricity from the grid, which is not always reliable as we have so many power cuts. So we also introduced solar energy, which we opted for it to be off-grid. Since we have unreliable electricity, it would be perfect to have an off-grid solar system so that when the electricity from the grid cuts off, we automatically turn on the on-grid solar. We also have natural gas that will be used for cooking. If you look at the image, we have a utility diagram for how our off-grid solar panels will be working. Potentials, you can see from the diagram, we have about 12 hours of maximum sunlight, which will give us 12 hours of maximum solar sunlight absorption as well as maximum power output. An average household uses 201 kilowatt hours per month. Our solar panels will be producing about 274.5 kilowatt hours per month, which is an excess of energy, which will also be channeled in other areas where we'll be using, for example, natural gas. Emissions. We have carbon dioxide emissions per area and carbon dioxide emissions that will be embodied emissions from the buildings and transportation. So we will have about 11 kilograms per square meter and about 2.8 thousand total carbon content per year. We calculated this carbon content by using the average total carbon dioxide content from the internet for the area within my country, as well as averaging with the average miles that are moved by a car or transportation within the area. That's how we got the carbon dioxide emissions. Our potential reduction, which is 27%, we calculated it by calculating using the excess amount of energy we'll produce from the solar panels, which will then feed into natural gas, which produces carbon dioxide. We saw that as a potential area that can be replaced with solar energy, as well as other heating appliances within the household that might use wood, firewood, or natural gas. That's the end of our presentation. We hope you enjoyed. I apologize you could not see my other teammate, Shai Verma. She was ill and could not come, but we hope you enjoyed our presentation. Thank you very much for your time and patience.
So there you have it, our grand prize winner, Team Creativity and Sustainability. But it doesn't end there. Jill Ivanko, would you like to make some comments about what the future holds?
Absolutely. I'm first of all so excited to share that we will have this competition running next year, and very proud to participate as Chart and myself. First, I want to congratulate everybody who won today, but also all the teams that submitted designs. We were really amazed by the amount of talent in the submissions that we received, which made our jobs difficult. But as you can see, there were many, many great designs that were awarded the 4 awards today. We hope that everyone who participated was able to improve your skills and learn how to bring more solutions to your communities that you live and operate in order to support the world's energy transition in the coming years and decades ahead to achieve all of the decarbonization goals that our individuals, companies, and our governments have with targets out there today. I'd like to again congratulate our winners of the 4 awards. Team Jellyfish with their Distinguished Design Award in Urban Planning. Team Aerodynamos with their Distinguished Design Award for Bold Creativity. Team Belrose Energy Company, the high schoolers who dared to take on the energy transition with their Distinguished Design, Next Generation. And finally, to our grand prize winners, Rosemary Moyo and Shai Verma, for rendering a comprehensive solution for a new community in the country of Zimbabwe. Congratulations on being the winners of our first annual Energy Innovator Award. For all the students watching, I invite and challenge you to deliver your own designs during our next year Energy Mentors competition. And again, I'm really excited to participate not only in this inaugural year, but in many, many years to come, as this is extremely important to the future of the energy transition. We anticipate that in next year's Energy Mentors competition, that will follow the same premise that we laid out today during the award ceremony. And we'll also, like anything else, incorporate lessons learned through the process that we went through this year. We hope that you're inspired by the trailblazers that you learned about during the last hour or so, and you can build on this momentum, not only for next year's competition, but every hour, every day, every week that we're looking to move this ahead. So don't wait for a competition, get going every single day and never stop being curious, learning from each other, creating to share ideas and barriers that hold us up from the energy transition. Make sure that you bring those innovative ideas forward, whether that's at school, whether that's your jobs, or whether that's in your personal life, because a lot of times your ideas come from sharing them with each other. So I'd like to also take a moment and thank Don for his leadership in establishing Energy Mentors, establishing competition and sharing all of the great ideas that Don has had throughout his incredible career with all of my fellow judges and myself. And I think a great platform for continuing to create innovation opportunities. So thank you, Don, for your leadership, and I'll hand it back to you to close out.
You're welcome, Jill. And I do also have to say thank you to you and your fellow judges. You gave your most precious resource, your time, to help make this competition a possibility. So thank you, Jill. Thank you, Vikas. Thank you, Moise. Thank you, Tony. Thank you, Juan. I really appreciate that you put the time in to help catalyze a rising generation. To you students who participated, thank you. We hope that you learned in the process. We hope you upskilled. We hope we put you on to continue on your path as you bring solutions to the world and bring forward energy prosperity and sustainability. To our energy mentors, enthusiasts, and supporters, we thank you for your moral and, yeah, even financial support. And soon a recording of the show will be available on our website, so please share it with your friends and other rising students to help catalyze a rising generation. And to you students who are thinking about next year, listen to what Jill just said. Take up the challenge, be empowered, form a team next year, upskill, take on the challenge, and set a foundation for your own career. So in the upcoming decades, you can deliver sustainable energy prosperity to the people in your own communities. So thank you all, and goodbye from Energy Mentors.